Sometimes in physics, it's useful to express units in different forms based on the magnitude of the number that the unit is attached to. So for example, if you have 1,000 meters, you may want to express it as 1 of something else. Now this something else is a unit as well, and it must be a unit of length because it has to be equivalent to the meter. And it must be something to show that 1,000 meters is equal to 1 of that. So they're equivalent. Now we're also assuming we're sticking within the SI system, so it has to be related to meters in some way. So how we can do this is add prefixes to the unit of meters to show that they're equivalent. So for example, in this case, 1,000 meters is 1 kilometer. And we just know, now that we have a K, that that's 1,000 meters. We're just expressing it in an easier form. So there are rules to these prefixes. You can't just come up with them at random. And the rule is that you can have a different prefix at every factor of 10. So 1 would be the meter, then 10 would be something equivalent to a something meter, so blank meter. 100 is equivalent to something else meter, something different from this, because 10 and 100 are not the same. And so on and so forth. You can go higher in magnitude or lower in magnitude, and you have different prefixes for each factor of 10. Or put in another way, every decimal place has a different prefix. So if you have a number like 10,000, your decimal place is here. If you move this way 1 decimal place, you have a different prefix. Here you have a different prefix, and so on and so forth. You can also go this way. Any change in decimal place, you can have a different prefix. And so all of these units, these unit prefixes, can be defined in a table, and that table looks something like this. I won't draw out the whole table because technically it's infinitely long, but you only need to deal with the ones that are close to 1, relatively close to 1. So if we start at 1, that's just your base. So in the case of meters, it's just meters. Then if you go up by a factor of 10, the unit is called, the prefix, is called deca, given by a dA. And so if you use meters again as an example, it would be decameter. Now if you go to 100, that's called a hecto, given by lowercase h. That's a hectometer, to use meters again as an example, and I'll use that throughout the scale. 1,000 is what we've done already. 1,000 is kilo, given by k. You get kilometer. Now I'm going to skip a few factors of 10 and go to a million. 10 to the power of 6 you can write it as. This is called mega, given by capital M, megameter. A billion is giga, capital G, gigameter. And now finally quadrillion is called a tera, capital T. Now if you know anything about computers, you may recognize these unit prefixes in terms of bytes, kilobytes, megabytes, things like that. So they work for many units. If you take out the example of meters, you can put any unit, you can put them in front of any unit and it'll work, as long as you're within SI system. And so, like I mentioned, we can go the other way as well. So 0.1 is called deci, not to be confused with deca. They're pretty close. That's a lowercase d, decimeter. If you go to 100th of a meter, or just the 100th decimal place, it's a centi, lowercase c, centimeter. Thousandth, you get milli, m, millimeter. Again, skipping to a millionth decimal place, 10 to the minus 6. Not millionth decimal place, but I guess millionth decimal place, yeah, that makes sense. You get micro, which is given by the Greek letter mu, which is just a U with a long tail, pretty much. Micrometer. 10 to the minus 9 is a nano, N, nanometer. And then finally, 10 to the minus 12 is called a pico. Picometer is an example. But like I said, you can use any unit in the SI system to like after these prefixes. So if you have, say, this value, a billionth of a second, you can look at the decimal places and say, okay, how many decimal places am I from here? 1, 2, 3, 4, 5, 6, 7, 8, 9. And so we're moving to the right, so it's negative 9. So we're negative 9 away. Well, we know that negative 9 decimal places is a nano, so this is equal to 1 nanometer. And that's much easier to write out than this. And so that is the purpose of having these prefixes, is it's much easier to express in this form. Now there are cases where we do want to express it in this form, and I will get into that in the next video to have easier ways to express large or small numbers like this in different forms. And that'll be the plan for the next video, so I'll see you there.